today we were talking. Let's see if I can do
Is
this.
this one easy?
That's crazy.
Medium.
That's actually crazy.
Why are you the way that you are?
There's no way.
Shh.
It's crazy.
Oh my gosh.
All right. You guys remember what this was called from last chapter? Sector. Okay. This is today's. We're not really doing sectors. We're doing this. What's this called? Arc. All right, the arc. You guys remember? So this is a central angle. Do you remember what letter we usually use for the central angle?
Oh my gosh. It was like the stupid Saturn thing.
Theta.
That's crazy. I call it that.
Yeah, theta. So today we're doing kind of two ideas. The arc can be, there's an arc measure, and then there's an arc length. There's kind of two ways to find the arc thing. So for measure, what they're talking about is angles. And for length, they're talking about like if you got a ruler out or tape measure, whatever, and measured how long is it from there to there, like 12 inches or 20 inches or whatever it is. So the arc measure, let's say, what do you think this angle looks like in here? Any guesses? I have a guess. Do I have a protractor on here? I don't think so. Do I have a protractor?
45.
Watch it be gigantic.
That's one very attractive.
Shrink.
It's crazy.
No, it's gonna take me an hour to get rid of it.
It's wild.
Two facts though. Oh, that thing is a low line.
That's crazy.
Well, it's about 60. Go away.
Yay!
Somebody get a 60?
Yeah.
You did?
I think we're in this.
I don't know how to get rid of that. So
Yeah, I
That's
guess.
crazy.
Yeah, I guess.
There it is.
Forrest, the only type of crazy is me.
Well, first
I'm going crazy.
Do not
This is the only time
duplicate.
I
The
said
first.
No, wait.
No, the first one's
That's
duplicate.
wild, dude.
Oh. Insane. No,
No.
it's not.
That was delete. Oh, darn it.
Like, actually,
You can't move it.
I regret my actions.
that. If there's something I could,
Oh.
if there's a way I could be mean without being mean, I would.
Okay. 60 degrees. So 60. 60 is not the same kind of measurement as like inches or feet, or it doesn't tell you how long something is. It kind of tells you how wide the opening is compared to a full opening, a full circle being 360. So if the central angle is 360, then the arc measure is if the central angle is 60, the arc measure is also 60 degrees. So the central angle is equal to the measurement of the arc it intercepts. Got it? So this is, from here to here is like 60 degrees. Well, guess what the whole circle is? 360. That gives you an idea of how much of the circle you're using. You're using 60 out of 360, so that's like 1/6 of the circle. But sometimes, so it doesn't matter if you draw the circle huge or if you draw it small. This arc could be 60 also. But if you're talking about, that's arc measure. If you're talking about arc length, that's like get the ruler out and this is like 15 inches and this is like 2 inches. Okay, arc lengths would be different on these two. Any guesses how we could find the arc length? It's kind of hard. Well,
Is it like the circumference divided by the number?
you're on the right track. Yes, you might understand it. So remember when we found sector area last chapter, like in that test we just took? We did the area of a circle times. Do you guys remember? Yeah, I think some people might have been the other class. Some people put a plus right there or something. But anyway, yeah, it's that pi r squared times theta over 360. Because this kind of just gives you the fraction of the actual circle. So arc length is a fraction of the what? circumference. Okay, so instead of this, you do the circumference of the circle. You guys remember the circumference, 2r pi. You could say diameter pi, but they're going to give us the radius. So 2r pi times the fraction of the circle, central angle over 360. And that is it. That is arc length. So these are angles, arc measure. These are like inches, feet, miles, whatever. Something like that. All right. We're also talking about naming the arcs and stuff like that. Let's get you out of there. Let's say this is an A and a B, and we'll put a C over here. Okay, if I just want to talk about the arc from A to B, it's called arc AB. So you put a little AB and then you put a arc symbol on top, kind of like a line segment, it's just curved. So that's arc AB. Well, what do you think if I want to talk about the arc from A to B, but I want to go the long way around, like all the way from here to here? What could I name this arc, the big one? From A to B. Somebody guess? ACB. So the first arc, the little one, if you're just going the short way, this is called a minor arc. So all minor arcs are less than 180, and you can just use the two letters, and the shortest distance between those two letters is the arc. Okay, if they use three letters, that's a major arc, going the long way around from A to C to B. That's a major arc. So you got to use three letters on the major arcs. Well, what if I just want to go from B to C? This is a diameter right here, by the way. Could I use two letters, or do you think I have to use three letters? Three. The reason being is that if I just say arc BC, it's not clear since it's kind of half the circle. It's not clear whether you mean this way, this arc, or this arc. So you have to use three letters. So if I want to go over the top, I have to say arc BAC or CAB or whatever. Okay, this is not a major or a minor arc from B to C. Guess what this is called? Semicircle, because it's half the circle, so it's a semicircle. So you have to use three letters, but it's only half the circle, so it's not a major arc, it's just a semicircle. All right, so let's go back to this. How many degrees would this arc be, like a semicircle? 180. This angle is 180. How many degrees is this? 120. You guys know she got that? These two add up to 180, straight line. So this arc is 120, and this arc's 180. All the arcs have to add up to 360, just like all the central angles add up to 360. All right, clear as mud. Fun with arcs. Okay, away we go. Number one. Name each described arc in circle O and then classify the arc as minor, major, or semicircle. I think maybe we'll go around on this one. It's kind of basic after you get the hang of it. Okay, so we're supposed to name the arc that goes from A to D that contains point E. Would A to D through point E, would that be a major or minor arc? Major. No. AED, that's the short way around, so that's only minor arc. So you could just call it arc AD. Comma, you're supposed to put it's a minor arc. A to D through point E. That's the short way. Less than 180 degrees. Okay, B, Eli. We're going from E to C through B. Is that a major or minor arc?
Major.
So what should we call it?
EBC.
Right. 3 letters, all 3 letters. Arc EBC, and you said major. Because it's a long way around. Forced A and C through B.
Semicircle.
It's a semicircle, and how should we name it?
ABC.
ABC. Let's draw a straight line. Alright, was that you, Grant?
What?
The hiccup?
Yeah.
Must run in the family. Okay, endpoints B and E containing A.
Semicircle.
Yep, and what do we call it?
BAE. It's arc. B.
You're right.
FE.
Well, technically we could use any letters in there, but might as well use the ones they gave us. Like we could use any point in the middle. So arc BAE is the same thing as arc BFE. But whatever. Okay. Let's jump back and get hope. Let's get some hope. Alright. Endpoints D and E containing F.
Major.
Yeah, that's the long way around. DFE. Major. Caden. C and F through E.
It's like minor.
Yeah, that's pretty minor. So on minors, remember you only have to use the 2 letters, so it's CF.
Rest and G. Hey, what's your favorite type of Waffle House from Waffle House?
Oh, is he that loose?
Okay, number 3. So we're looking for the measurements here. These are angles. We're not looking for the length yet. So I guess Shannon, arc AB would be how many degrees? Well, do you guys see where angle BOC is 50, right? So if angle BOC is 50, what's angle BOA? 130. So what's the measurement of arc BA? 130. Any questions on that? Don't make me draw it. Number 5. Anna. So we're looking for arc ED.
It would be 180 minus 95.
That is correct. So if you look at that 50 and the 45 and the angle we're looking for, together they make a straight line. So they should add up to 180. So she said 180 minus 95, which is correct. And the answer is
85.
85.
This is like mathematics.
Yeah, don't say it's easy because that jinxes us. The second part's always harder. But I don't think it's too bad. I think you guys will be fine. It's a good Wednesday assignment. 7 is the measurement of arc BAD, B-A-D.
That's a bad.
That's crazy.
Yeah, yes. So she said 360, I think, minus 95, because it's everything except for those 95 degrees in there. So 360 minus 95 is 265. All right, number 9. Let me look at 8, right congruent statements for any congruent minor arcs. On number 8, they found 2 answers. Like arc. Remember, like vertical angles are congruent and all that stuff? But you're supposed to say what arcs are congruent. So, for example, since angle BOC is the same thing as angle AOE,
You put there.
then arc BC is congruent to arc AE. But there is another congruent pair of arcs besides that.
Do we have to?
Yeah, go ahead and try 2. Yeah, I'll let you guys look at it. Okay, number 9. How do we find the arc length? Find the value of the variable L. Arc length. So what was the difference between this and the other? Okay. 2 through 7 is the measurement of the arc, degrees. 9 through whatever, we're talking about lengths of the arc, like something you could find with the tape measure. Anyway, we're using the formula we talked about earlier. It's circumference. You guys still remember that from last week? Hopefully you got that right on the test. Times the central angle over 360. Okay, anyway, that's the formula we're using. So what is the radius for number 9?
Big
8.
numbers.
So we're going to do 2 times 8 times pi times the central angle, 75 degrees, over 360. So the book did kind of what they did last chapter. They put 2 answers. They put the exact answer with pi in the answer. Then they put the decimal answer where they plug pi in the calculator. So you can kind of choose, I guess. I guess I'm going to put the pi answer. Reduces to 10 pi over 3, which is about the same thing as 10.5. This is not an area because it's just a length, so it's not squared. So you can put one of these. I'm going to stick with the pi answers because I can do that without a calculator. Number 11. So on 11, they don't give us the central angle, but they do give us the arc length. So I'm going to plug everything into the formula just like before. So it's 2 times the radius, 15, times pi, times the central angle over 360, that's the one I don't know, should equal the arc length, which they give us is 35 pi over 4. Okay, there's a few ways to do this, but we need to do algebra to get solve for theta. How do I get theta by itself? How about, what's 2 times 15? Times pi is 30 pi. Actually, okay, what's going to happen if I divide both sides by pi? Yeah, because pi is like a multiplied value, it just goes away. Yeah. So we have 30 times theta over 360 equals 35 over 40. So all I did was divide the pi's away. 2 times 15 is 30. Alright, what do you guys think? How can I keep going here? Trying to solve for theta. Okay, yeah. 30 is the multiplied value. We can get rid of it by dividing by 30. What about the 360 though?
Multiple.
Right. 360 is a divided value. So to get rid of a divided value, we have to multiply by 360. So, yeah, that'll give it to us. I believe this is 105. Now we're talking about a central angle, so it would be degrees. Here's a slightly easier way I could have done that. If you're multiplying by 30, it's kind of like, you can think of it like this, 30 over 360 times theta. Like 30 goes on top, and you can write it like a fraction. So we could have just divided by 30 over 360. Kind of turns two steps into one step. That would have worked also. Alright. Hopefully that wasn't too confusing. To get rid of a multiply, you have to divide. To get rid of a divide, you have to multiply. That's basically all we did. 13. Here we go. Kind of the same thing, but this time we're missing the radius. So it's 2 times radius times pi, which we don't know the r, so I'm leaving it blank, times the central angle over 360 should equal the arc length, which they give us. All right, so what can I do to solve that for r? Remember what I did first on the last one? You may remember? I divided both sides by pi. They go away. What else can I do? How do I get rid of the 2?
You divide it.
Divide it. How do I get rid of the 48 over 360?
You multiply by 60. Or which one do you?
This is a multiply value, right? So you can just divide by 48 over 360. 2 is multiplied to r, this is multiplied to r, so you just divide them both. Divide by 2, divide by 48 over 360. Dividing a fraction is the same thing as flipping it and multiplying it, but probably just easier to put divide. Let's see here. This is me doing it by hand. Divide by 4 is 12 is 4, 30, 215. Okay, I got 2 millimeters. All right, any questions? Clear as mud? If you said times 360 and divide by 48, that would work also. Some of you might have been saying that. Times, we could have put times 360, kind of like last time, and divide by 48. That would have worked as well. Number 14. What's weird about 14?
Oh, we know a lot of stuff except for the actual part.
The arc that they give us does not go with the angle that they gave us. Any bright ideas? Game plans? Right. So if you find the angle of the giant arc, like do the normal stuff and find the angle in the giant arc, and then do 360 minus that angle, and that'll give you the little angle. Yes. Good job, Shannon. All right, 15. Hush, it's enough. Okay. Circle P and circle Q are congruent, which means, guess what? They are the same size. So circles are the same size. Then it says segment AB and segment CD are congruent. Those segments are chords. So if you have circles that are the same size with chords that are the same size, guess what we know about the arcs? They're the same. And the angles, the central angles are the same. So kind of everything's the same. So if angle APB is 80 degrees, then what is angle CQD? 80 degrees. Number 17. If angle APB is 75 degrees and CQD is 75 degrees, central angles are the same. What do you think, what's true about segment AB and CD?
They're the same.
They're congruent. Kind of saying number 15 backwards. If the chords are congruent, the arcs and central angles are congruent. If the central angles are congruent and the chords are congruent, works both ways. All right, number 19. It's on the other page. Okay, 19. Find the missing length. So we're still doing arc length again. So using the same formula. They just didn't draw a picture for us, but we're using the same formula as 9 through 14. So 2r pi times angle over 360. The arc measure is the same thing as the central angle. So number 19, 2 times r is 2 times 3 times pi times angle over 360. That should give us the arc length. Did I copy that right? Yeah. Okay, this reduces to 536 times 6 is 5/6 pi. So 5/6 pi is the same thing as 5 pi over 6, right? I think the book wrote it like that. Because pi is like pi over 1, so you can just put it on the top where you multiply it. (21). This time we don't know the middle, the central angle. So 2 times radius times pi times angle over 360 should equal the arc length 7 pi over 2. This is like number 15 or whatever number it was, 13. How do I solve this for theta? The pi's will cancel out. There's multiple options of what to do.
Multiply by 360.
Multiply by 360. Divide by 2. How about divide by 14? Get it all in one go. You could divide by 2 and divide by 7, and that would work. But yeah, this will do it. Anyway, got rid of everything, right? all that's left is theta, so it's gonna equal whatever this is. I think it's 90 degrees.
Yep.
Alright. Oh no, never mind. $22. Well, I told the other class, well, it's Wednesday, so we didn't have as much time in the morning class. I just told them 22 would be bonus, so you guys can try 22 for bonus. The perimeter of the sector just means like how far around the sector is it? I recommend drawing a picture to start.